Hello friends. Now let us learn about measurements of screw threads. To find out quality of threads elements, the following elements of screw threads are measured. First is major diameter, next is minor diameter, then effective or pitch diameter and thread angle. Then first we will start from measurement of major diameter. It is most commonly measured by bench micrometer. And how this bench micrometers is used for getting the great accuracy? The bench micrometer is used for measuring the major diameter. The fiducial indicator is used to ensure all the measurements are made at same pressure. Here the fiducial indicator is there, here micrometer head is there, here two supports are there, here two holding centers are there as shown in figure, here measuring anvil is there, here and here. So here benchmark bench micrometer without work holding center is shown in figure. Now let's understand in detail. Measuring major diameter of an external threads. Calibration. A calibrated setting cylinder having approximately the same diameter has is the major diameter of the thread to be measured is used as a setting standards. The setting cylinder is held between the anvil and the reading of micrometer R1 is noted as shown in figure. Two holding centers are there and it is held with a standard cylinder. Step 3, then the cylinder is replaced by the thread workpiece and the new reading R2 is noted for the same reading of fiducial indicator. Here it is shown in step 3, step 3 in diagram. After standard cylinder holding and measuring, it is removed and it is replaced by the screw thread, and measurement has been reading has been noted. The major diameter of screw thread is given by D is equal to S plus R2 minus R1, where S is the diameter of setting cylinder, R1 is the micrometer reading on setting cylinder, R2 is the micrometer reading on screw thread. Then measuring major diameter of an internal thread. An indirect approach of measuring internal thread is obtained by obtaining the cast of the thread. Now next is measurement of minor diameter. Measuring minor diameter of an external threads. Here the floating carriage micrometer is used to measure the minor diameter for externally threaded elements. How to how it works? Floating carriage micrometer. The floating carriage uh, diameter measuring machine is a bench micrometer mounted on a carriage as shown in figure. It is suitable for almost all kinds of threads. The V piece available in various size having suitable radii at the edge are used along with the setting standards. Then working procedure. The threaded workpiece is mounted between the centers of the instruments, and the V piece are placed on each side of the workpiece with base against the anvil of the micrometer. After mounting the workpiece, the reading R2 is noted as shown in figure. Then the thread workpiece is replaced by a standard reference and the corresponding reading R1 is taken as shown in figure. After removing the threads measurements, it's measured with the help of standard cylinder diameter. The minor diameter of screw thread is given by D is equal to D plus R2 minus R1, where S is the diameter of cylinder gauge, R2 is micrometer reading on threaded cylinder, R1 is micrometer reading on cylindrical gauge. Now moving to the next slide, measuring minor diameter of an internal thread. Still now we have studied about the external thread. Measuring minor diameter of an internal threads. Minor diameter for internal threads are measured by using two methods. First one is taper parallel methods and next is roller methods. Now what is taper parallel methods? The taper parallels are pairs of wedges having reduced and parallel outer edge. The diameter across their outer edge can be changed by sliding them over each other. Here it is shown two pairs are there which can be slide one upon other. Inside the internal threads, taper parallels are inserted and it is just stayed until form contact in each in contact is established with minor diameter. Here has shown in figure, the both the pairs are slide till the it touches on the threads as shown in figure, and the micrometer reading has been noted. Here it is shown. Next is method is rollers. In this method, precision rollers are inserted inside the thread and proper slip gauge inserted between the rollers as shown in figure. Two rollers are available, here one and here two, and in between slip gauges are there. The minor diameter is equal to the length of this slip plus twice the diameter of the roller. So the length will be length of this slip gauges plus the diameter of the roller. Now next slide is measurement of pitch diameter. Pitch diameter or effective diameter measurement is carried out by the following methods. There are three methods. First one is thread micrometer method, two wire method and three wire method. Let us understand. First is thread micrometer method. The screw thread micrometer is designed to measure the pitch diameter of a screw thread up to 0.01 millimeter of accuracy. It is similar to an outside micrometer, but has the following difference. First difference is the movable spindle is pointed. Here the movable is pointed. Then the end of the anvil is the same as the screw thread to be measured. The reading is read in similar way as in case of outside micrometer. Different pairs of interchangeable V anvils and spindle points are provided with the micrometers. As shown in figure, the spindle and the anvil are touched till it come in contact with the pitch. Next is two wire methods. The effective diameter of a screw thread may be ascertained by placing two wires or rods of identical diameter between the flanks of the thread and measuring the distance over the outside of the wires. Wires of exactly known diameters are chosen such that they contact the flanks at their straight portions. The wires used are made up of hardened steel to sustain the wear and tear uh, in use. These are given a high degree of accuracy and finished by lapping to suit different pitches. Then, if the size of wire is such in contact with the flank at the pitch line, it is called best size wire, which can be determined by geometry of screw thread. Now, working procedure. Screw thread is mounted between the center and wires are placed in the grooves and reading M is taken. As shown in figure, one wire is in upper side and next wire is in lower side and M is measured. The effective diameter E is calculated as E is equal to T plus P. T is where T is dimension under the wire is equal to M minus 2D, where M is dimension over the wires. Small d is dimension of each wire. P is difference between the effective diameter and the diameter under the wires. We will understand details of P, value of P. The P is a value which depends on diameter of the wire, pitch and angle of the screw thread. The P value can be derived in terms of pitch, diameter of wire and thread angle using the geometry of measuring setups. If P prime is equal to pitch of the thread, then for with both thread P is equal to 0.9605 P prime minus 1.1657 D. For metric thread P is equal to 0.866 P prime minus D. Now, three wire method. Three wire method is the most accurate than the two wire method. In this method, three wires of equal precise diameter are placed in the groove at the opposite side of the screw. Here, three wires as shown in figure 1, 2 and 3. So, it is known as three wire method. In this, one wire on one side and two wires on the other sides are used. This method ensures that the alignment of micrometer anvil face parallel to the thread axis. Now, the working procedure. Basically, the principle of both two wire and three wire methods are same. Hence, same setup are followed to perform the measuring operations. Applications of two and three wire methods. Two wire method is used when floating carriage micrometer is available for the measurement, whereas for ordinary micrometer is used for the measurement, a three wire method should be used. Now, next is measurement of pitch. It can be done by following methods. First one is pitch measuring machine, tool maker microscopes, screw gauge and profile projector. First we will see about pitch measuring machine. A relatively accurate, simple and convenient method of measuring the pitch of screw thread is by means of pitch measuring machine. The screw to be measured is held between the centers and the machine is fitted with stylus of such a size that contacts the thread flanks approximately at the pitch line when it is lies in the groove. Spring loaded head permits the stylus to move with the flank of the thread and down into the next pace as it is moved along. Let us understand with the figure working procedure. The stylus is accurately positioned between the two flanks by ensuring that the pointer T is always opposite its index mark with readings are taken, and the pointer is accurately placed in position the micrometer reading is noted. The stylus is then moved along into the next thread space by rotation of the micrometer and a second reading is taken. Here the micrometer is there, here work holders are there, here indicating unit is there, and here stylus is there. So while taking the reading, the stylus will touch into the pitch and reading as is noted down, and for taking the next reading the micrometer is rotated and next reading is taken. The stylus is then moved along the next thread space by rotation of the micrometer and the second reading is taken. The difference between the two reading in the pitch of the thread reading are taken in this manner until the whole length of the screw thread has been covered. Now next instrument is tool maker microscope. It is optical measuring machine equipped for all types of measurement for small parts. It creates and enhances an accurate shadow of the parts which reassembles the objects. Here the figure is shown tool maker microscopes. Now let's see the working procedure. Work table is placed on the base of the instrument. The optical head is moved on a vertical column and it can be moved up and down. Here it is shown, this can be moved up and down. Workpiece is mounted on a glass plate. A light source provides horizontal beam of a light which is reflected from a mirror by 90-degree upwards towards the table. Here the lamp is there, collimating lens is there, here mirror is there which reflects that 90-degree. The image of the outer line of the counter of the workpiece passes through the object of the optical head. The image is projected on a ground glass screen on the work table. The measurements are made by means of cross lines engraved on the ground screen ground glass screen. Here has shown in figure, this light source passes from collimating lens, then mirror it is reflected, then workpiece it is passed, and then after it can be observed at by eyepiece. Next is screw pitch gauge. This tool is not used as a precision measuring instrument. Here the figure is shown. It allows the user to determine the profile of the given thread and quickly categorize the thread by shape and size. As there are numbers of different type of threads, there will be different categories of the threads. Now working procedure. To use a thread gauge, the user must first match the type of thread gauge. We have to match the types of thread gauge. For example, attempting to measure metric thread with an imperial gauge will not return accurate result. So here it is said that if one thread is of different, and then we cannot measure, it will not give an accurate. So first we have to identify the best threads, and then after the different leaves has to be matched. To determine the correct gauge, a process of trial and error may be needed if the screw is of unknown origin. So trial and error method should be followed. Once the correct gauge is determined, the user should extend one of the leaves of the tool and press it against the thread portion of a screw, as shown in figure. How it is? If the thread cut into the leaf matches the spacing of the thread, then the user can read off and thread pitch stamps into the leaf. Here the indication is there 1.0, 1.5, 1.25. So different relief will be there for size of the pitch. If the fit is not good, the user should try a different leaf. So it is an not that much accurate compared to other, so it is not used for precision measurements. Next instrument is profile projector. In this method, the projector magnifies the profile of the specimen and display this on the built-in projector screen. Here has instrument is shown. On this screen there is a typically a grid that can be rotated 360 degree, so that XY axis of the screen can be aligned with the straight edge of the machine part to examine or measure. This projection screen displays the profile of the specimen and is magnified for better ease of the calculating linear measurements. An edge of the specimen to examine may be lined up with the grids on the screen. For their simple measurements may be taken for distance to other points. Here as shown in figure, the light source lamp is available, then emulating mirror is there, then it is diverted at 90 degree, then glass stage plate is there, here object is placed, then projection lens, and later on roof prism, then again it can be observed in screen. Then next is measurement of thread angle. Can be measured by using following instruments: tool maker, microscope, and profile projector. In this method, optical projection oblique shadow is used to check the thread angle by using protractor, as shown in figure. This is the protractor and we are measuring the angle of this. For better accuracy of result, it is necessary to project along the direction of the screw thread, example along the helix angle. Here we can measure the angles by using the projector. This is the last slide of this topic, that is screw thread metrology. Screw thread measurement is required for dimensional control to ensure a certain consistency of the fit. So if measurement is not done, there are probability of failure of the threads and there may be breaking of the threads. Screw thread inspection is performed by using the thread gauge and some individual measuring instruments for measuring different thread elements. Different methods of for measuring major diameter, minor diameter, effective diameter, pitch and thread angle of the thread element has been discussed. Toolmaker microscope and profile projector can be used to perform all types of linear and angular measurements for small thread elements. Here these are the advanced instrument used for measurement of linear and angular measurements. Here we are ending the chapter, that is screw thread metrology. For detailed proper view of the slides I have attached in the description. Thank you.